And we're doing the tangent graph by hand specifically because it has several undefined values, and on the calculator it gave me a domain error. So when I go to do it by hand, I'm going to start by just thinking through my exact values. So the tangent of 0 is 0. The tangent of 1 pi over 6, or 30 degrees, is a rad 3 over 3. The tangent of 2 pi over 6, or 60 degrees, is a rad 3. 3 pi over 6 is where tangent is undefined. That was 90 degrees. 4 pi over 6, I got to stop for a minute and think about this, would be 4 sets of 30 degrees, or 120, which has a reference of 60. So the answer is going to be the same as my tan 60, but in the second quadrant, this rad 3 will be negative. So you see how I did that? In 5 pi over 6, now I want 5 sets of 30, so that's 150 degrees, has a reference of 30, so it'll have the same answer as this, but in the second quadrant, it'll be negative. 6 pi over 6 is just plain pi, and the tangent of pi is 0. Nice job. After that, 7 pi over 6 is 7 sets of 30, or 210, which has a reference of 30. So it'll have the same answer again as my 30, and in quadrant 3 will be positive. Are you noticing a pattern here? Are you noticing that I'm having the same two answers in between the zeros and the undefineds? That's what makes this easy. There's really only two answers I need to know other than 0 and undefined, and that means that this one here at 8 pi over 6 is probably going to be the rad 3. 9 pi over 6 is the other place I was undefined, and now I can go back and see a very distinct pattern here. I went 0, rad 3 over 3, rad 3, undefined. Backwards, negative rad 3 over 3, negative rad 3, negative rad 3 over 3, 0, back up. This is like I'm starting all over here. Rad 3 over 3, rad 3, undefined. What do you think is going to be next? The negative rad 3. Now, once I've decided on this pattern, all I need to know next is the fact that there's really only two numbers on here that I can't quantify, that I don't have a specific value for. Some of them are positive and some of them are negative, but there's only two numbers I can't recognize. And they are rad 3 and rad 3 over 3. So if I just turn those two numbers into decimals, my table is done. Do that now. Okay, now that I've got my table of values complete, next I'm going to start to make my graph. And when I go to make my graph, what I need to put in first is how am I going to deal with those places where the graph is undefined? How does one graph undefined deadness? We actually did this earlier in the year. It's not a point. It was a vertical dotted line. We called it an asymptote. Vague recollection? Anthony's like, nope, got nothing for you, Petrella. And they're going to go at 90 and 270. That's an undefined place, or an asymptote. And you can't basically hit that line. It's kind of like a shield. You can get really, really close to it. You can hug it all you want, but you can never touch that line. So as I plot these points, it helps to keep that in mind, because when I think about the fact that I can't touch that line, it kind of tells you what the graph's going to do as it gets close to that line. I'm going to start with my right 0, up 0, right 1, up 0.6, right 2, up 1.7. Worth noting at this point that you'll recall the sine and cosine graphs never went above 1, because we said sine and cosine are never going to be above 1. But the tangent graph goes high because tangent can. All coming together. Next, I'm going to jump over that green dotted line and go down to negative 1.7, then negative 0.6, then 0, then 0.6, then 1.7, back down, then 0.6, then 0. And that's what my graph is plotted as. The question is, how does it come together? And the answer goes something like this. As I get moved toward that asymptote, it helps to always move toward the asymptote. I can get as high as I want, but I can never touch it. So as this thing gets closer and closer and closer to the asymptote, it's basically going infinite. Now again, I typically graph from left to right, but I just said it's easiest if you graph toward the asymptote. So I'm going to start this way and go toward the asymptote, and that's how I know that one's going infinitely down. And now I'll start back here at this 0 point and go toward this asymptote. Oops, I missed my point, but I'm supposed to hit it. And that one's going to go infinitely up. And then I'm going to come back over here and go toward the asymptote, and that becomes my tangent graph.